two projects. In this video, we are going to see CSKG4APT, a cybersecurity knowledge graph for advanced persistent threat organization attribution. Introduction. CSKG4APT is a groundbreaking cybersecurity innovation that combines knowledge graphs and deep learning to predict and analyze complex cyber threats. This fusion enables efficient analysis and informed decision-making, revolutionizing the landscape of cybersecurity by empowering security experts to uncover and proactively counter threats. Objective of the project: to enhance advanced persistent threat APT detection and attribution, the project aims to create CSKG4APT, a cybersecurity knowledge graph framework. It aims to develop a comprehensive platform for processing APT network data by integrating ontological knowledge, representation, and deep learning methods. The ultimate objective is to develop a model that can accurately detect APT attacks in test data. This will improve cyber threat intelligence, equip security analysts with effective tools for precise threat detection, and support processes for network security decision making. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDE of Python 3.7 version. To execute this project, we have designed the following modules. The first module is Upload APT Attack Dataset. This module facilitates the upload of the APT dataset to the application and identifies various cybersecurity attacks present in the dataset. Subsequently, it plots a graph illustrating the frequency of appearance for each attack type. The second module is Knowledge Graph from Dataset. This module involves inputting the entire dataset into a graph algorithm to construct a knowledge graph. The resulting knowledge graph visually demonstrates how attacks are interconnected with network features. The third module is Preprocessed Dataset. This module handles the preprocessing of the APT dataset before training the model. It involves removing missing values from the data. The dataset is further shuffled, normalized, and then split into train sets and test set in the ratio of 80:20. The deep learning algorithm VILSTM with GRU layers will utilize the training set for model training. The next module is Run VILSTM with GRU algorithm. In this module, the deep learning algorithm VILSTM with GRU layers is applied to the project. VILSTM with GRU, that is bidirectional long short-term memory with gated recurrent unit, is a sophisticated neural network architecture. BILSTM processes data in both directions, capturing temporal relationships, while GRU's gating mechanism manages information flow, making it ideal for complex pattern recognition like APT detection. The algorithm is trained using 80% of the dataset from the previous module. The trained model is then used to make predictions on the test data to calculate the prediction accuracy. The next module is Comparison Graph. This module is responsible for creating a comparison graph that visually represents the performance metrics of the proposed algorithm. The graph plots various metrics such as accuracy, precision, recall, and F-score, enabling a comprehensive assessment of the algorithm's effectiveness. The last module is Attack Detection from Test Data. This module handles the detection of APT attacks in the test data. We can upload a test dataset to the application. The proposed algorithm analyzes the test data and predicts the presence of the APT attack. Execution of the project. To execute this project, first we need to open the code folder. This is the dataset folder in which I have APT attack dataset. So, to implement this project, we have used APT text dataset, network dataset, and then applied BERT bidirectional encoder representations from transformers algorithm on text data to convert into numeric vector, and this vector contains average frequency of each words from the dataset. So this is network information as BERT vector, and we can see first four rows contain words from the dataset and remaining rows contain average frequency of each word under that column word name. This dataset will be input to deep learning algorithm to train an APT attack detection model. Close this dataset, and this is the test data. This is the model folder in which I have pickle files and .hdf files. These files contain algorithm information, and these files can be loaded into the project code during runtime to utilize the trained models. This is the dataset link text document in which I have a link to download the required dataset. These are Python main code files, and this is the run.bat file. Instead of executing the project in command line interface, we have created this Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload APT Attack Dataset button. A dialog box opens. Select the dataset and click on Open. So in this graph, on x-axis I have APT names, and on y-axis I have attack count. Close this graph, and in the text area we can see a confirmation that the dataset is loaded, and these are top 5 rows of the dataset, and there are 266 columns in the dataset. Now click on Knowledge Graph from Dataset button. So from dataset we got knowledge graph with various attacks, and now close this graph and click on Preprocess Dataset button. So here we can see total records found in the dataset are 1415, and these total records are split into train and test in the ratio of 80:20. So now train set includes 1132 records and test set includes 283 records. Now click on Run BI LSTM with GRU algorithm button. So in this confusion matrix, on x-axis I have predicted class, and on y-axis I have true class, and the diagonal boxes represent the correct predictions and the other boxes are the misclassifications, and we can see there are only few misclassifications. Close this, and in the text area we can see the performance metrics of BI LSTM with GRU layers model, and now click on Comparison Graph button. So in this graph, on x-axis I have accuracy, precision, recall and F-score of BI LSTM with GRU, and on y-axis I have metric values. So we can see the model is doing well in all the performance metrics. Close this, and now click on Attack Detection from Test Data button. A dialog box opens. Select the test data and click on Open. So we can see in the square brackets, this is the test record, and after the square brackets, after the arrow, we can see prediction. For this test record, it has predicted the APT attack as Hurricane Panda. So we can scroll down to see the predictions for all the test records. And the conclusion here is the CSKG4APT project showcases the potential of combining knowledge graphs and deep learning techniques in cybersecurity. By creating a robust knowledge graph model for APT attacks, the project accurately detects and attributes persistent threats within network data. This combination enhances cyber threat intelligence and provides security professionals with proactive threat mitigation tools. CSKG4APT is a significant step forward in fortifying network defenses and safeguarding digital ecosystems.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.